The first section of notes today is add, subtract, rational expressions. Again, rational expressions are fractions which contain variables. First problem today is 5 over 2m plus 4 over 2m. When adding fractions, the denominator must be the same. In this case, they're both 2m, so our answer will have 2m for the denominator. The numerators, we can add those. 5 plus 4 would be 9. Always check and see if the fraction can be reduced. This one cannot be reduced, so your final answer is 9 over 2m. Last question for the section is 2y plus 1 divided by y minus 1 minus y plus 2 divided by y minus 1. Again, both fractions have the same denominator, y minus 1, so that will stay the same in our answer. For the numerator, we want to combine like terms. We have 2y and y. Keep in mind we're subtracting. It's a good idea to put parentheses around the second fraction. So we have 2y minus 1y, which would just be y. We also have 1 minus 2, which would be negative 1. Again, the minus sign goes to the y and also to the 2. Our answer so far is y minus 1 over y minus 1. Keep in mind if you have the same term on top and bottom, you can actually cancel those or divide those out. And our final answer, if everything gets canceled out, there's always a 1 in front, so your final answer would just be 1. The next section of notes is titled Add, Subtract, with different denominators. First problem is 7 over 3a plus 2 over 5. Again, before we add two fractions, the denominator or bottom number has to be the same. In this case, we'll look at the two numbers, 3 and 5, and we want a common denominator that will be 3 and 5. For example, we can multiply this one by 5 to make this 15, and this one we can multiply by 3 to make that 15. Also, the first fraction has an a, which means the second fraction also needs an a. When we're multiplying by 5, keep in mind you want to multiply the top by 5, and the second fraction will be multiplied by 3a. Rewriting our question, we have 5 times 7, which is 35. 5 times 3 is 15. A comes after it. Plus 2 times 3a would be 6a. And 5 times 3a would be 15a. Again, once you have common denominators, the same numbers on both fractions, you can combine those together. 35 plus 6a. Normally in algebra you'll write the variable first, which would be 6a plus 35. Variables and numbers, again, cannot be combined, they're separated. 15a would stay the same. Always remember to double check, see if you can reduce fractions or factor out fractions. 6 and 35 cannot be factored. 5 goes into 35 and 15, but does not go into 6, so this one cannot be reduced. Final answer would be 6a plus 35 over 15a. Next question, which is the last question for the section. 2 over 5x to the 8th power plus 3 over 3x to the 6th power. Again, before we add fractions together, both denominators must be the same. If we do the coefficients, 5 and 3, our common denominator would be 15. So the 5 will have to multiply by 3, and the 3 will have to multiply by 5. Also, the variables must be the same. If this is x to the 8th, this one's x to the 6th. We can actually change this one into x to the 8th by multiplying by x squared. X to the 6th times x squared would be x to the 8th. And keep in mind, if we're multiplying by 3 for the denominator, 3 gets multiplied in the numerator. 5x squared in the denominator would be 5x squared in the numerator. Rewriting our question, we would have 3 times 2, which would be 6. 3 times 5x to the 8th. 3 times 5 would be 15. X to the 8th would come over. The numerator, 3 times 5 would be 15. X squared would go after it. And 3 times 5 would be 15. X to the 6th times x squared would be x to the 8th. And again, when you have the same denominator twice, you can add those together. Normally, again, the x's go first, so we'll have 15x squared plus 6 and divided by 15x to the 8th. Again, always double check, see if fractions can be reduced. In this case, we have 3 numbers, 15, 6, and 15. Each of those we can divide by 3. 15 divided by 3 would be 5, x squared. 6 divided by 3 would be 2, and 15 divided by 3 would be 5. To factor out x's, each term would have to have an x. There's no x on the 2, so this fraction would stay the same, and our final answer would be 5x squared plus 2 over 5x to the 8th. The last section of notes today is titled Polynomial Denominators. Polynomial, again, would be a variable that has a plus or minus sign after it. Question for this section is 9 over m plus 2 plus 8 over m minus 7. Again, adding fractions, we need the same denominator before we can add these fractions. When you have a polynomial like m plus 2, this cannot be changed to m minus 7, but what we can do is multiply by m minus 7. Same thing if you have m minus 7 over here, m plus 2, we'll have to multiply the other side, so both fractions have the same factors, m minus 7 and m plus 2. Keep in mind you'll multiply the numerator also on each side by what you're multiplying the denominator by. M minus 7 on top and bottom, and m plus 2 on top and bottom. Solving this one, when we multiply 9 times m minus 7, this will be like distributive property. we'll do 9 times m and 9 times negative 7. 9 times m would be 9m, and 9 times a negative 7 would be negative 63. For the denominator, you can leave it in factored form, which would be m minus 7 and m plus 2. If we add to it the second fraction, again we're multiplying by 8, so this will be distributive property. 8 times m and 8 times 2. 8 times m would be 8m. 8 times 2 would be 16. The denominator also again would stay the same, m minus 7 and m plus 2. Once you have the same denominator, both fractions have the same two factors, we can add those to make one fraction. The numerator, we have 9m. We can combine that with 8m, and we're adding those together. 9m plus 8m would be 17m. Then we have negative 63 plus a positive 16. That would be negative 47. The factors for the denominator would stay the same, m minus 7 and m plus 2.